Okay. Finding composite functions. This is a skill that we learn in algebra. We learn it in pre-calculus without knowing that it applies so much to calculus that I think if students were aware of how much they're going to use it in calculus, that they'd really spend a lot more time on it. So let's take a really quick look at this. Here's a problem. It says finding composite functions. First off, we're going to define our two functions. So let f of x equal this function and let g of x equal this one. And we're asked to find f of g of x. What I also want to say about this is this notation is common, but it's not any more common than this notation, which is to find f of g of x. I like the second notation better because it reminds me of stuff like when you're asked to find f of 3. And remember, let's say you were going to be asked to take f of 3. So you take your f of x, right? And f of x up here says it's x squared minus 16. So you'd say, right, and you'd say, well, then f of 3 would equal every place I found an x, I put a 3. Right? And you'd get 3 squared is 9, and 9 minus 16 is 7. So that would be your answer, right? This is no different than that. So when you're asked to find f of g of x, the first thing I would do, and I'm going to stay with this nice pink color coding, is I would say it's f of x is equal to, and I'm leaving this blank on purpose, is x squared minus 16, isn't it? Well, we're not asked to find f of x. We're asked to find f of g of x. So all we have to do here is every place that we found an x, which would be here, we put this in. We put in our square root of x, right? And then, of course, we know that the square root of something squared is that thing itself, isn't it? Remember that the square root of x is the same as saying x to the 1/2 power. So the square root of something squared is just that thing. So f of g of x is simply equal to x minus 16. Right? We could go back and do it the other way. We could be asked to find g of f of x, keeping in mind that, in my opinion, it would be more accurately written this way. And we'd do the same thing, but we'd do it backwards. We'd start with this function. So we know that our g function, our g of x function, is equal to square root of x. So we have square root. But instead of putting the square root of x in, right, we would say that we would apply this. We put our f of x in there, wouldn't we? Because this is we're asked to find f of g of x, and f of x is x squared minus 16. This one is a little bit more interesting because here we have to think about something called a domain issue. And domain issues answer the question, are there any forbidden values? And there are here, because if you think about this, you cannot take the square root of a negative number, right? So you can't have a negative number in here. So that tells us that x squared minus 16 must be greater than or equal to 0, right? It can't be less than 0. So we would just start to solve here, wouldn't we? And as we solve, we would move this thing over, we just do some algebra here, and we'd add 16 to both sides, all right? And we'd get x squared is equal to 16, right? And then we take the square root of both sides, and we get x, is greater than or equal to plus or minus 4, which makes it really weird. And I almost wish I didn't bring this one up. But this one's really weird because we're squaring this number, so no matter what we do, it's going to be positive here. So we have to make sure that when we square this number, no matter what number it is, that it's the squared value is no smaller than 16. So our answer comes out looking like this, and I'll show you why. That the absolute value of x is greater than or equal to 4. Because look, here's negative 4 here, and here's 4 here. If we put in positive 4, we'd get 4 squared is 16, and 16 minus 16 is 0. That's fine. If we put in positive 5, we'd get 5 squared is positive 25 minus 16. That works. But look what would happen. If we went over to negative 4, put in negative 4, well, negative 4 squared is 16, and 16 minus 16 is also 0, and that's okay. And if we went farther out and we put in negative 5, well, that would work too, because negative 5 squared is 25, and 25 minus 16 makes sense. That gives us a positive, a non-negative number in here. But what if we put 3 in? If we put 3 in, well, if we put 3 in, 3 squared is 9, but 9 minus 16 is a negative number. It doesn't work. If we put in negative 3, that wouldn't work for the same reasons. So what we find out is it's these numbers here, between negative 4 and 4, not including those two values that don't work. So our final answer here would be this. So we started off talking about composite functions and ended up talking about domain issues. So welcome to the world of math. Good job, you guys. Any problems or questions, please comment, and I hope you subscribe to my page. If there's something I can do to be helpful, let me know.